All right, let's take a look at this. He runs with a purely horizontal velocity of 5.6 meters per second and hits the water 1.8 seconds later. Okay, so let's see. Let's draw a picture of this. Here he is. He's running. So we know he's in the air for 1.8 seconds. We know. There he goes, right? He's going 5.6 meters per second. Of course, he's going to like this, right? All right, I think you always know these guys. You always know this, this, and this for a cliff problem, right? Any projectile motion, you know these two. And for cliff problems, we know that, right? I feel like this thing is telling you this and this and this and this. It's almost telling you everything, right? So see if you can fill in what it is you know. Okay, I'm going to pause for a moment here. All right, so let's see. 5.6 goes here. 0 goes here. This is always 0. This is always negative 9.8. This is 0 because it's a purely horizontal velocity, right? And then the time is 1.8. Okay, so let's look in the vertical direction. I'm going to find x using this guy. Right, our initial velocity is 0, so that whole thing goes away, right? So that equals 1/2 negative 9.8 times 1.8 squared. All right, 0.5 times negative 9.8 times. All right, it's 15.876 negative. So this is equal to. All right, let's see. Let's find the final velocity. Let's use this guy. All right, so it's 0 plus negative 9.8 times 1.8. All right, negative 9.8 times 1.8. Negative 17.64. All right, now we're done with the... Come on, baby. I feel like I'm going side to side. Okay, let's do the horizontal here. Okay, and then really all we ever do is we use V as x over t, right? Okay, so x is going to be vt, right? It's a triangle problem, right? So x is 5.6 meters per second for all of 1.8 seconds, right? 5.6 times 1.8. That's 10.08. So that's our... All right, so let's answer questions here, okay? Did I get them right? Ooh, I did. I got some of them right anyway. Okay, so how high is the cliff? We are going to use this to find the height of the cliff, right? So for A, question A, we're going to use this guy. Right, so the height of the cliff is, if it's 15.876 meters down, then I would say that the cliff must be 15.9 meters. I'm just rounding that answer. I'm not making it negative because I think it's weird to say that to get from the top to the bottom of the cliff is down 15.9, right? Okay, so B says, how far from the base does he land? That's going to be this guy, right? So it's going to be 10.1 meters. I'm just rounding these to 3 digits. Let's see. What is his final vertical velocity? That's going to be this guy here, right? So let's see. Don't forget to make a negative. I'm going to say negative 17.6 meters per second. And then for the final thing, we're going to have to erase all this, and I'll draw a picture of it. Okay? So just, I'm going to erase it in 3, 2, 1. There we go. All right. So remember that the horizontal velocity was 5.6. And the vertical velocity was, and remember to draw these guys, 0.64. Okay, so remember to draw them tip to tail with the tail of the with the y component sprouting from the tip of the x. So you can do it the other way, but I'm just trying to be consistent here. Make sure you use arrows. So the x component's an arrow, the y component's an arrow, right? And then be sure to label which angle you're finding. I always find that one. So that theta is the inverse tan of 17.64 over 5.6. So second tan, 17.64 divided by 5.6. And that is 72.3 degrees. All right, let's see. Final velocity of impact. And then, we need to find the magnitude. So let's find the speed. All right, that's going to be the square root of 5.6 squared plus 17.64. Again, don't use the minus sign. It'll have surprising results sometimes. Okay, so square root of 5.6 squared plus 17.64 squared. And that is 18.5 meters per second. That's, of course, the speed, right? 18.5 meters per second. Ta-da! Yeah.